So I'm gonna spend 15 minutes or so exploring large language models. For me, it's kind of fundamentally there's two things that large language models do. One is understand things, and the other is generate things. And so underneath those two umbrellas, there's a whole bunch of different use cases for them. As kind of Paul was explaining, the future potential of them is huge. And it's nice, and we have to think about what that future potential is, and we have to think about those use cases, and how do we make them kind of robust enough to be able to be used kind of in live customer conversations. But then what can we do with them today that we can actually get some leverage from? And so we've done a bit of research, and we've been kind of looking at the various platforms that have been making various announcements and stuff like that. So we've got a little bit of a map here in terms of like what features are the platforms implementing, which of those kind of features do we think are kind of ready for you to sort of experiment with and use today, which are a little bit more kind of future thinking, but good to pay attention to. And so I'll start with a joke. Who was at the speakers' dinner on Tuesday? A couple of people. Okay, a little bit more than this morning, so some people have heard this joke before. I am recycling jokes at the moment. This is a joke from ChatGPT. Why did the conversational AI agent get into trouble with its boss? Because it kept responding, "Sorry, I didn't understand that," whenever it was asked to do something. I'll wait for you to laugh. I thought it was quite funny. Don't blame me, blame GPT. So it's interesting, and what ends up happening with these technologies is that the same thing happened with Alexa, which is that in the very early days, they get used for kind of novelty-based use cases. It's all fun and games, and we're asking it to tell jokes, and we're asking it to write us novels and all that kind of stuff. And then what ends up happening is they move into more kind of like practical, utility-based spaces, like can it actually help me get stuff done? Can it write an email that I'm happy to have it send? Can it manage a conversation with a customer and we're confident that it's actually able to do that and be kind of consistent when it does it? And then the final stage from a kind of technology point of view is monetization. Once you've proven the utility, you're able to monetize the technology. And Alexa kind of got stuck at the productivity phase. It didn't really get into productivity. It was mainly about games, and therefore monetization didn't arrive. The app ecosystem, mobile apps, went through the same thing. First kind of app was that, do you remember the one where you'd tip your phone up and there'd be a pint on your phone, and you'd go like this, and your pint would disappear? So the early apps were all like fun games basically. Then they moved into more kind of productivity-based, and you started to get your email on your phone and all that kind of stuff. And eventually, once there's enough kind of usage built up, you can then monetize them, and all of a sudden, there's a whole kind of ecosystem that was built around the App Store, and every app today is monetized in some way, shape, or form. Right now, I think with large language models, we are well and truly in the novelty phase of them, and that's really where kind of, it's mainly explorative in many cases. There's some companies, Paul was saying, Webby or there, they've been using them for the last 2 years. There is some companies that have been using them effectively over the last number of years for very specific use cases. But some of the things that we see around, the large language models are just gonna, take over the world and all this kind of stuff. I think we're a little bit, we're not quite there yet. I'm assuming you're all familiar with the hype cycle. Raise your hands if you are familiar with Gartner's kind of hype cycle. Yeah, of course. So I'm kind of like not teaching you how to suck eggs here. Where do you think we are from a kind of large language model perspective on this hype cycle? Who thinks we're down here? Show of hands. Oh, interesting. Who thinks we're up here somewhere? Who thinks we're either at the very peak of it now? Couple. Who thinks we're kind of down, we've already been past the hype and now we're down here to the trough of disillusionment? No one. Okay, fair enough. I would say we're probably about here, but I think I actually agree that it may be a little bit earlier on, because it's like, I was thinking, how much more hyped could it possibly be? Like all this ChatGPT stuff, and all of a sudden every person and their dog is now using LLMs, or every second person on LinkedIn is a large language model expert, and all of a sudden we're like, half the world are prompt engineers and all that kind of stuff, and it's like, how much more hype could it possibly be? And then in 1 week, literally, like on Tuesday, Google says, we're releasing Palm into Google Workspace, and then like half an hour later, GPT-4 is announced, and like 2 weeks before that, Microsoft announces GPT-3 or ChatGPT in Bing, and it's kind of like, it made me think that actually we might even be just here, because it just seems absolutely constant. And the question is, for a business that wants to try and apply this technology, what do you pay attention to? What's kind of worth your time and what is complete bullshit? It's a very difficult question to answer. This is GPT-4. Took the bar exam and ranked around about the 90th centile, sort of in terms of its results it got from the bar exam. So whereas kind of earlier versions lacked kind of real world kind of context, GPT-4 is beginning to get a little bit smarter in that respect. It's a little bit better at logic and things like that. And so definitely, I think that we're obviously going to continue to see, I think Oksana mentioned GPT 25. God knows what that's going to be like, but it's obviously that these things are getting better. And so what are they good at is the question that we need to sort of answer. Over the last, since probably the turn of the year, every platform that exists in the conversational AI space has been exploring how to utilize large language models. Some of them have actually completely rebuilt their platforms to incorporate large language models. Some platforms who have sort of emerged over the last 2 years, like Zero Shot Bot and Noble and others, they're kind of foundationally building on large language models as to underpin their kind of core platform. But I did a bit of analysis last week when one of our speakers pulled out and I was forced to throw together this presentation to try and see what features are these platform providers actually focusing on, like what are the features? And so there's a kind of commonality. Some of these are unique to certain platforms, but a lot of them are fairly common. Anything purple is kind of design features. When I say design, I'm talking more around like the either data generation or response generation and those kind of things, entity mapping, synonyms, things like that. Pink is still design, but it's more specific to dialogue management. Anything yellow is happening at the interaction layer, so actual live in real time on the front end with customers. Anything blue is agent assist, so capabilities that are there specifically to help contact center agents. There's more than that, but I've run out of space. And then anything kind of black or gray is anything that's there to optimize the experience. And there's a lot of stuff in here that's really interesting, right? There's a lot of things like, let's have a look. We've got dynamic suggestion chips. So in a chat conversation, at the moment, if you wanted to have these little shortcuts, which are, if somebody asks this, then we'll suggest that, and these 3 things might be relevant to you, being able to dynamically populate what those next suggestions are based on the LLM's understanding of what the previous context of the conversation was is fairly kind of interesting. It's less risky because you're not it's all kind of button clicks, so you can sort of like predefine what those things are. There's things around like contextual sort of dialogue handling, which a lot of companies have displayed, like, the Cognigies and Core AIs and Razas and stuff like that over the last number of weeks, where anything that doesn't fall in scope, if you like, of the conversation, the LLM will kind of pick up, and it'll use the context of the conversation so far, so it understands what you've kind of been through and what the stage of the conversation that it's at, and it will use the LLM to kind of mop up anything that doesn't quite fit the parameters of the conversation, then like re-prompt you or something like that to kind of get you back on track. And so if you say, for example, I don't know, I'd like to order a pizza, and you go through that pizza journey, and then halfway through you kind of say something that's entirely relevant, like what time do you close tonight or something. It will manage the context of that conversation, knowing that it's expecting you to give it a topping or whatever, but it'll answer the question and then bring it back with a prompt that says, okay, now let's carry on with the pizza toppings. So it's able to manage a lot of that complexity of dialogue design that ends up tying us up in knots a little bit. Anyone who's ever designed a kind of a conversation interface using a flow chart, when you get into anything, in fact, not even mildly complex, but even semi-complex, you end up tying yourself in a whole bunch of knots because the conversation can go in lots of different types of places. And so this is, I'm yet to see it necessarily proven in the wild, but it's definitely something that I think is very interesting. Any golf fans in the room? Anyone play golf, Taras? Do you actually play golf, or are you just telling me there's 5 minutes left? Okay, fair enough. I better get a move on. I thought we might be able to go for a quick knock after this there. So anyone play golf? Quick show of hands. Yeah, cool. Fair enough. So my dad is a keen golfer. He's not a very good golfer, and so that's probably where I get my slice from. But he has this kind of saying, which is drive in for show, put in for dough, which means that anyone can hit a ball a mile, and it looks really cool, but what really matters is putting the ball in the hole at the end. That's the hardest bit. So the sexy stuff is all well and good, but when it comes down to brass tacks, it's the boring stuff that really matters. And I think that's where we are with large language models right now. It's the boring stuff, the stuff that's not very sexy, but it's very practical, where it can add some value. I'm not going to have time to go through all of this, but what do we think is kind of like a good confidence score for an NLU system, for an intent, to classify an intent? What kind of confidence score would you be happy with? 85, 90 is pretty high. Okay, that's good, that's good. So we were looking at using synthesized training data to train intents. And that's a very obvious use case. It's something that one of the first things people think of is we can use it to train intents. But how effective is it at doing that is the question. And so we have this chatbot, which is it's actually in the debt collection space, so it's very similar to what Paul was talking about here. And there's things that happen not very often that you don't necessarily, in this instance anyway, it's not a massive company, so the traffic's not massive, but there's kind of like long tail use cases where you might not want to spend a whole load of time and effort, and in fact there might not even be data available because it's so low volume for you to get enough data to train an intent to properly classify an utterance. And so we kind of experimented with, okay, well, can we just throw this example to a large language model, have it generate some training data, throw that back into the model and see what happens. And in these three intents here, asking for help with my account, asking when my next payment date is, and asking to create a regular payment. That's what we did here. And the average intent, the average confidence, and this is literally based on just taking synthesized training data, was 85%, 83%, and 82%, which is not at that level, but it's not bad, you know. With a little bit of massaging, a little bit of tuning, maybe some examining here where the confidence level is a little bit lower, I think you'll be able to kind of get it into a pretty decent position. And this dashboard here, which we've knocked up, will basically show you the confidence level of those three intents based on the turn in which the conversation happens. So Paul was saying earlier on that different things mean different things in different parts of the conversation. So in the example that Paul said there, if someone says, I can't pay in this debt collection kind of use case, if they say, I can't pay at the beginning, it might be because they don't have any money. If they say they can't pay at the end, it might be because the website's broke. So it's a perfect example of how different turns in the conversation result in different requirements. And so you can see here at some turns in the conversation, when we ask it, your balance is due later, do you want to pay now? There's a little bit of an issue here, and also if we can't find your case details, there's more of an issue here. So different turns in the conversation perform slightly differently. And so training data is a good, I think, a good place to start. It's not very sexy, but it's kind of proven itself a little bit. Another thing is classification. So there's some use cases here where the whole concept of an intent-based NLU model will start to break down. I know that there's companies like Core AI, who's in at the back here with their Knowledge AI, and Raza have been talking about this a lot, which is over time the requirements to manage intents will start to diminish as large language models get more sophisticated. And so ingesting a knowledge base or ingesting content from a website, for example, turning that into the ability to query it means that you don't need the intent. You can just match the content with the query, use the large language model to do the interpretation, and Bob's your uncle. I don't know how that is working in production. I know there's a couple of companies who've got these features, but I'm yet to see it actually out there in the wild, so I don't know exactly how that kind of fares. But we've been doing a bit of research into, not in the intentless model, but if you were to use a traditional intent-based model, obviously one of the tricks of that is that you need to have data, as we've said, to be able to train that model, and also then you need to be able to accurately classify. And there's three ways of doing that. In this typical intent-based model, you've got a bunch of training data. Every piece of training data belongs to a bucket, and the job is to try and kind of like predict what kind of utterance belongs to which bucket, basically. And so we were doing a little bit of experimenting here. So most of the intent-based models in most of these kind of transactional use cases, they're not actually that bad. You might have to disambiguate a little bit where there's grey areas, but they're not that bad, especially if you want to collect certain bits of information from people. What's really challenging for a typical NLU model is where you get these really long kind of utterances from people. So in this instance, someone says, I've done a debt relief order, which included my bank details with you. It's been through the insolvency service, and it's been agreed and finalized, but you're still trying to take payments from my bank account every day. A typical NLU system will just fall flat on its face with anything like that. And if anyone's got any live chat kind of conversations going on their website, you'll know that most of the time when someone starts a conversation, especially if it's a highly emotive use case, they'll just ramble on at you. And 9 times out of 10, if you want to try and automate that, first things you're going to say is, I'm sorry, I don't understand that, or how can I help you? So you're not taking any context from what the customer's just said, and you're just starting everyone from the same place. Whereas running that through a large language model, a long utterance, which a typical NLU system won't classify, is actually bringing back a 0.9 confidence score on the informed insolvent intent, which is the right intent. So it's a good way of classifying longer kind of utterances. At scale, who knows how kind of effective that is, but it's proven to be all right. We spoke earlier on about collecting personal data, so I'm not advising that, that you do this, but I wanted to just demonstrate the effectiveness of a large language model of extracting entities. And so in here, you've got a name, which it's extracted pretty well. Further on, you've got an account number, another name, you've got a phone number, and it's extracted those entities pretty well as well. But it has got the wrong intent. That's not the right intent for this. There's a different intent, which is around setting up a staggered payment. So what I suppose the point is, and I'm going to wrap up because we have lots more other stuff to get on with, is there's some boring stuff, which is really boring, which is probably not teaching you anything new. I'm not expanding your horizons with this, but hopefully showing you how it's actually performing in practice gives you a bit of confidence that in some of the boring stuff that really matters, large language models actually are pretty effective. But the risk is still there, which is that because they're generative on the response side, it's very unpredictable, and so it still needs management, and it needs a lot of kind of quality assurance and things like that. And the one bit of paranoia I have is that as everyone races into developing LLM-based solutions, that we lose track a little bit of some of the stuff that we've been touching on today, which is using the technology responsibly, using it transparently, being able to audit the decisions that it's making, being able to kind of ensure you've got consistency both from a kind of customer experience perspective and the results it's delivering for the business. So I'm a little bit concerned that we're all just racing into it, and we're getting ahead of ourselves, and there's a bit of an arms race going on in terms of who can use this stuff more innovatively without necessarily thinking about how we can also do it responsibly. I don't have a solution for that. It's just an observation that all this attention and all this hype drives a whole bunch of behavior, and we forget about some of the stuff that we've been talking about today, which is around privacy, responsibility, transparency, which is crucial to making this stuff work at scale in large organizations. So I've got a few other slides on here. I'm happy to talk more about this afterwards, but we are going to have to wrap up and welcome our next speaker in about 2 minutes' time. So thank you very much.